Hello, and welcome to Learning Outcome 3, Understanding Object-Oriented Programming, OOP. In today's session, we will explore the question, how does object-oriented programming enhance software development? OOP is a programming paradigm that revolutionizes software design by organizing code around objects, which combine data and behavior. This approach promotes modularity, reusability, and scalability, enabling developers to build more efficient, maintainable, and adaptable software systems. OOP structures software design around objects, not functions. Objects represent real-world entities with properties and behaviors. For instance, an account object in a banking program might have attributes like balance. It might also have methods like deposit and withdraw. This organization makes code more maintainable and understandable. Encapsulation involves wrapping data and methods in a single unit. It restricts direct access to some components, protecting data integrity. For example, a class might have private variables only accessible through methods. This ensures secure data handling. Encapsulation is a cornerstone of OOP. Inheritance allows one class to acquire properties of another. This promotes code reuse and logical hierarchy. For instance, a car class can inherit from a vehicle class. The car can then move and honk without rewriting code. Inheritance simplifies complex systems. Polymorphism means many forms and allows methods to behave differently. The same method can produce different results depending on the object calling it. For example, a dog and a cat might both have a speak method, but the dog barks and the cat meows. This flexibility is a powerful feature of OOP. Abstraction focuses on showing essential details while hiding complexity. Users interact with objects without knowing the inner workings. For instance, a shape class might have an area method. Users know shapes have areas, but not how it's calculated. Abstraction simplifies interactions in OOP. OOP offers modularity by dividing code into objects and classes. It promotes reusability through inheritance and libraries. Programs can scale easily without breaking existing structures. Encapsulation enhances data security. Polymorphism simplifies code expansion. Modern OOP languages include Java, Python, and C++. Java is used in enterprise and Android development. Python combines OOP with functional programming. C++ supports both procedural and object-oriented paradigms. These languages demonstrate the versatility of OOP. Procedural programming is based on functions and procedures. OOP is based on objects and classes. In procedural programming, data is separate from functions. OOP combines data and methods in objects. OOP offers higher reusability and better data protection. OOP is used in software development, game design, and web development. It simplifies complex software design by promoting modular code. In data science, it encapsulates data processing in classes. OOP is essential for maintainable and scalable code. It's a staple in modern development. Consider a student class in Python. It has attributes like name and grade. The display method prints the student's data. This shows encapsulation and simplicity, creating objects from this class model's real-world entities efficiently. Understanding OOP encourages clean and logical code structure. It reduces duplication through inheritance. Maintenance and upgrades become easier. Developers can work collaboratively by separating components. OOP forms the foundation for modern frameworks and APIs. Object-oriented design allows code reuse across projects. Classes like employee or customer can be reused without rewriting. Inheritance lets new classes build on existing ones. This reduces duplication and development time. It encourages building libraries and frameworks. Encapsulation groups related data and methods together. It hides internal details, making the program secure. Sensitive information can be made private within a class. Methods allow safe access to data. This reduces unintended interference. OOP improves clarity and scalability in software development. It models real-life entities, making systems easier to understand. Modularity allows independent testing and modification. New functionality can be added with minimal disruption. OOP supports scalability as new features emerge. OOP simplifies maintenance through modularity and reusability. Changes in one module usually don't affect others. Errors can be traced within specific classes. New features can be added without rewriting the system. This reduces downtime and maintenance costs. OOP is ideal for complex systems involving multiple entities. It's suitable for projects needing long-term maintenance and flexibility. OOP is effective in team collaborations and large code bases. However, it may not be necessary for simple programs. Evaluate project needs to decide on OOP usage. Objects are the building blocks of OOP, representing real-world entities. They encapsulate data and behavior in a single unit. Objects are created from classes, which define their structure. They manage complex data structures efficiently. This leads to clean, modular, and reusable code. Creating an OOP program involves several steps. Start with problem analysis and object identification. Design classes and intermediate representations. Implement classes and objects in code. Use data structures like arrays, stacks, and queues. Finally, test and document the program. Compiling transforms source code into machine-readable format. Debugging identifies and fixes errors in the program. Use tools like debuggers and IDEs for efficient debugging. Breakpoints help inspect values during execution. Mastering these techniques ensures error-free and maintainable software. IDEs combine code editors, compilers, and debuggers. They streamline the development process. IDEs offer code assistance, integrated debugging, and code management. Debugging tools help trace errors and verify data structures. Use these tools for efficient program development. In conclusion, object-oriented programming, OOP, enhances software design by promoting modularity, reusability, and efficient management of data and behavior. By mastering OOP principles, developers can create maintainable and scalable software. Additionally, understanding compilation and debugging ensures that programs run reliably and effectively. Thank you for watching this video. If you have any questions, please feel free to send a message via WhatsApp at 07,484,361,688. Thank you for your attention and see you soon.